Let's review L'Hopital's rule for indeterminate form 0 over 0. When we're evaluating the limit as x approaches a of f of x over g of x, and both f and g approach 0 as x approaches a, we end up with this indeterminate form 0 over 0. So L'Hopital's rule says that if we evaluate the limit as x approaches a of f prime of x over g prime of x, notice this is not quotient rule of differentiation. We're taking the derivative of the numerator and dividing it by the derivative of the denominator. If this limit is equal to L, then the original limit, x approaches a of f of x over g of x, also equals to L, where L could be a finite number or infinity or minus infinity. But if we keep getting indeterminate form 0 over 0, we'll have to apply L'Hopital's rule again and again until we no longer get that indeterminate form. So let's look at the following example. Limit as x approaches 0, 1 minus cosine of 3x divided by the sine of 5x squared. As x approaches 0, clearly both numerator and denominator approach 0, so we do in fact get indeterminate form 0 over 0, and that means that L'Hopital's rule can be applied, and we're going to do that. So we'll evaluate another limit, next limit, which is limit x approaches 0 of the derivative of the numerator, which is 3 times sine of 3x over the derivative of the denominator, which is 10x times cosine of 5x squared. Now, let x approach 0. Once again, numerator goes to 0, denominator goes to 0. We still end up with an indeterminate form 0 over 0, and we apply L'Hopital's rule once again. Take the derivative of the numerator now. And this is the limit x approaches 0. 9 times cosine of 3x. And to take the derivative of the denominator, we'll need to use the product rule. So it is 10x times negative 10x times sine of 5x squared plus 10 times cosine of 5x squared. And let's rewrite this so it'll be a little bit simpler to take the limit. So we're not doing L'Hopital's rule here, just rewriting what we already have. Limit x goes to 0. The numerator stays 9 times cosine of 3x, but in the denominator, we'll write it like this: 10 times cosine of 5x squared, and then it is minus 100x squared times sine of 5x squared. Now let x approach 0. The numerator, cosine of 3x approaches cosine of 0, which is 1, times 9. So the numerator approaches 9. In the denominator, this part right here, as x goes to 0, we get cosine of 0 times 10, which is 10. And then the second part goes to 0, and our final answer is 9 divided by 10. So to summarize what we just did, we were evaluating the limit as x approaches 0 of 1 minus cosine of 3x divided by sine of 5x squared. And after applying L'Hopital's rule twice, we found that this limit is equal to 9 over 10. For more videos, visit www.mathprepvideos.com.